Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we're going to start a new lecture on chapter number 3, which is under chapter number 3, which is measure of position. Last week we already looked at measure of central tendency. We already know how to calculate mean, mode, and median from ungrouped data and group data, right? So we also know what is the characteristic of mean, mode, and median. And we also learn what is the relationship between mean, mode, and median when mode is high, when mode is larger than median, larger than mean. So we're going to get a skew to the right distribution when skew to the left distribution when mode is smaller than median, smaller than mean, so we will get a skew to the right distribution. And when we have mean equal to median equal to mode, and then it is a symmetrical distribution or normal distribution. So today we'll learn another measure, which is measure of position, right? Measure of position. So under measure of position, we will learn quartiles, percentile, range, and quartile and percentile only, right? So to learn quartile, you need to understand the concept of median. So concept of calculating median. So the explanation of quartile is same as median, right? So if you look at this one, quartile divide group of data into 4 equal parts. So if you remember median, we divide data into 2 equal parts. So I mean we're going to get we want to divide based on the middle value. So this is having 50% of the area, and this also have 50% of the area. This is for median, right? For quartile, we're going to divide the data into 4 equal parts. Means we're going to cut 3 times. This is first cut, second cut, third cut. So this is going to be quartile number 1. So this is quartile number 2. This is quartile number 3. So the first quarter consists of 25% of the data. First quarter, we're going to cut first 25% of the data. For the second quarter, we're going to cut first 50% of the data. And the third quarter, we're going to cut 75% of the data, right? So this is what quartile means. So let's say we want to find quartile number 1. So for quartile number 1, let's say this is 25% of the data. We cut 25% of the data, and the balance is 75%. So means, how to interpret this one? We have 25% of the data having value less than quartile number 1, while another 75% of the data having value more than quartile number 1. So the interpretation is same as median, right? So let's say we want to find quartile number 2. So for quartile number 2, we're going to divide the data into first 50%. Quartile number 2, we're going to cut the data first 50%. So quartile number 2 also same as median. So that's why quartile number 2 are also equal to median. We cut the data first 50%. So how to interpret this one? 50% of the data having value less than quartile number 2, while another 50% of the data having value more than quartile number 2, right? So for quartile number 3, right? So we're going to cut the data for the first 75%. So this is 75%, right? So we can interpret, we have 75% of the data having value less than quarter number 3, while another 25% of the data having value more than quarter number 3. So this is how we interpret quarter 1, quarter 2, quarter 3. And Q1 is representing quarter 1, Q2 is quarter number 2, Q3 is quarter number 3. So this is what is the definition of quartile, right? So in this topic, we will learn how to calculate quartile for group data and ungrouped data. So let's look at computation of quartile for ungrouped data. So for ungrouped data, is same as median. The procedure is same as median. First, we need to first step, we need to arrange data in an ascending order. Right. Second step, we need to position the each of the data. And second step, we need to find the position of quartile I, where I equal to 1, 2, and 3. So means that we can find quartile 1, quartile 2, quartile 3, right? So position of quartile I is equal to I multiply with n plus 1 divided by 4, right? So I kita boleh ubah lah, whether I is equal to 1, so n plus 1 divided by 4. When I equal to 2, quarter 2, 2 multiply with n plus 1 divided by 4. When I equal to 3, and 3 multiply with n plus 1 divided by 4. And step number 3, we locate the position of the median. Locate the quartile I value, right? So this is the step of calculating quartile for ungrouped data, right? So let's look at example number 32. So example number 32, so we have we want to calculate quarter number 1, second quartile, and third quartile for the following data, right? So how to do this? So same step as median. First step is we need to arrange data in ascending order. So first step, arrange data in ascending order. First is 5, 8, and then 12. And then we have 15, 17, 20, 23, 25, and 30, right? So my style is I will position each of the data, right? Since this is a position number 1, this is position number 2, 3, 4, 5, 6, 7, 8, and 9. So step number 2, we need to position of quartile I. So let's say position of quartile 1. So this is 1 multiplied with n is 9 plus 1 divided by 4. So this is going to be 2.5. So we want to number 1 is the value of position between 2 and 3. And quarter number 2, 2 multiplied with 9 plus 1 divided by 4. So this one should be equal to 5, right? And position of quarter number 3, 3 multiplied with 9 plus 1 divided by 4. So this one should be equal to 7.5. Right, step number 3, we're going to locate a value for quartile I. Right, so value for quartile number 1 is a position of 2.5. 2.5 is between 8 and 12. So 8 plus 12 divided by 2. So this one should be equal to 10. So quartile number 1 is equal to 10. Quartile number 2 is position of number 5. So position number 5 is 17. So quartile 2 is 17. And quartile number 3 is 7.5. Position of 7.5 is between 23 and 25. So 23 plus 25 divided by 2 should be equal to 24. So we already have the value of quartile 1, quartile 2, and quartile 3. So quartile 1. So interpretation. Quartile 1, 25% of the data is less than 10, while another 75% of the data more than 10. So this is how you interpret quartile 1. For quartile number 2, 50% of the data is less than 17, while another 50% more than 17. For quartile number 3, 75% of the data is less than 24, while another 25% of the data more than 24. So this is how you calculate quartile 1, quartile 2, quartile 3 for ungrouped data. So, so far, do you have any question? Okay, you can comment on the chat room if you have question. No. Right, good. So now look at example number 33. So this is 2. Right. So example number 33. So find the first, second, and third quartile for the following data. Right. So same procedure as before. First step, we need to arrange data in ascending order. So if you look at this data, it's already arranged. It's already is an arranged data lah. So it's starting from 14, 23, 28, 38, 49, 51, 57, 65, 71, and 84. So my style, I would position each of the data. So this is position number 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we know that we have n equal to 10. Right? So second step is we need to find the position of quartile 1, position of quartile number 2, position of quartile number 3. Position of quartile number 1 is I equal to 1 multiply with n plus 1 divided by 4. So n is equal to 10 plus 1 divided by 4. So it should be 11 over 4. It should be 2.75. Right? So quartile number 2, position of quartile number 2, right? 2 multiplied with 11 divided by 4, it should be equal to 5.5. For position number 3, 3 multiplied with 11 divided by 4, it should be equal to 8.25. So this is not a value of quartile 1, quartile 2, and quartile 3. This is just a position where quartile number 1 located, quartile number 2 is located, quartile number 3 is located. So number 3, we need to locate quartile number 1. So quartile number 1 is between 2 and 3, where the position is 2.75. Right, 2.75. So it's not if you want to locate the quartile number 1, it's not same as example number 32. So you need to do some manipulation. So we want to find the data starting from 23, right? And then we want to find 75% of the difference between 28 and 23. So we're going to get 0.75 since kita ada 2.75 kan. So kita ambil 2 dekat sini. So this is position 2, 23. And 0.75, right, dekat belakang ni, kita letak dekat sini. Right? And then multiply with the difference between position number 3 and position number 2. So 28 minus 23. Right? So this one should be equal to 23 plus 3.75. So this one should be equal to 26.75. Right? So, and you need to make sure 26.75 is between 23 and 28. Right? So this is the value of quartile number 1. Right? So this is very tricky sikit. Right? So hope you understand how to calculate quartile 1 when you have more than, it's not equal to 2.5, it's 0.275. So if you want to find quartile number 2, quartile number 2 position is 5.5. So 5.5 is very simple, straightforward. So the value should be between 5 and 6, 49 and 51. 49 plus 51 divided by 2. So this one should be equal to 50, right? And then position quartile number 3. So this one, the position is 8.25. So 8.25 is between 65 and 71. So position number 8 is 65. So you letak 65 dulu. Plus, so di belakang ni position dia 0.25. So 0.25 multiply with the difference between 71 and 65. So 71 minus 65. So this one should be equal to 66.5. So this is how we calculate quartile number 3. Right? So far, do you have any question of calculating quartile for ungrouped data? Any questions so far? Right, good. Move to the next topic, which is computation of quartile for group data. So for group data, like median, quartile can be computed by means of formula or estimate by less than or give. So in median, we can calculate median for group data using formula, and we can find median from less than or give, right? So this is the formula. Formula are same as median, right? So the difference is instead of we taking 100% of the data, so we take 25%, 50%, or 75% of the data, depend on which quartile that you want to compute. So the first value is lower class boundary of the quartile class, whether quartile number 1, quartile number 2, or quartile number 3. So this is a position of quartile. This is a cumulative frequency before the quartile class. This is the frequency of the quartile class, and this is class size of the quartile class, right? Example number 4. So in example number 34, right? As median, the summer step as median. So this is your class size, and this is your frequency, and then you need to calculate the cumulative frequency class. So step dia sama macam median. So cumulative frequency class start from 0 before the first class. So this is 10, 22, 47, 55, 72, and the last one is 80. So the summation of F is equal to 80. Right. So first step is we need to find the position of quartile. Right. Let's say position of quartile I is equal to I multiplied with summation of F divided by 4. So this is the formula of calculating position of quartile. Ada mention dekat atas tak? Tak ada kan? Right. So this is how we calculate, how we position the quartile I. So where I is equal to 1, 2, or 3, where quartile number 1, quartile number 2, quartile number 3. Step number 1 is we need to position the quartile class. Step number 2 is we need to locate quartile I class. And then step number 3, this is the same step as how to calculate median in group data. And then we need to locate so we need to locate the quartile I class. So the quartile I class should be the frequency, cumulative frequency should be equal to the value of quartile I or next greater to the quartile I, position of quartile I, right? And then if you have a class size, then we need to use a formula, right? Let's look at example number 34. We try to calculate quartile number 1. So we need to first find position of quartile 1. So position of quartile 1 multiplied with 80, the summation of frequency divided by 4. So this one should be equal to 20, right? And then position of quartile number 2 means 2 multiplied with 80 divided by 4. So this one should be equal to 40. Position of quartile number 3, 3 multiplied with 80 divided by 4. So this one should be equal to 60, right? Now, second step, we will locate the position, the quartile 1 class. Quartile 1, position of quartile 1 is 20. So we look at the cumulative frequency class. We need to find the cumulative frequency equal to 20. So we don't have cumulative frequency equal to 20. The next greater to 20 is 22. So this is a position, quartile 1 class. This is class for quartile number 1. Right. So since we already identify the class for quartile number 1, right? So now we will find quartile number 1. Quartile number 1, lower class boundary. So this is not a class boundary because the upper class limit before the first class is 799, then lower class limit is 800. So the lower class limit here is 799.5 until 899.5. So this is 699.5, 799.5, and this is 899.5. And this is 999.5 to 1099.5. This is 1199.5. And this is 1199.5 until 1299.5. So the lower class limit for quartile number 1 is 799.5. So we need to plus. So the formula is, after lower class limit, we need to input the position value. So the position of quartile number 1 is 20 plus or minus, right? Right, minus. This is minus cumulative frequency before quartile number 1. So which is equal to 10. Right? Divide by frequency of quartile number 1, which is equal to 12. Right? And then multiply with the class size. So the class size is 899.5 minus 799.5, which is equal to 100. Right? So quartile number 1 is equal to 882.83. So this is the value of quartile number 1. Right? So for quartile number 2, the position of quartile number 2, so position of quartile number 2 is 40. So we need to find the class for quartile number 2. Next greater of 40 is 47. So this, the blue color is position for class for quartile number 2. Also equal to median class. Right? So the blue highlight is class for quartile number 2. Right? So the lower class limit of quartile number 2 is 899.5 plus the position of quartile number 2 is 40, right? 40 minus cumulative frequency before quartile number 2, which is 22, divide by frequency of quartile number 2, which is equal to 25, multiply with the class size 999.5 minus 8.5. So the quartile number 2 should be equal to how much? Quartile number 2 should be equal to 971.5. Right? So if you understand my lecture last week, so you will understand how to calculate quarter 1, quarter 2, and quarter 3 for group data and ungrouped data. Right. So now we move to the next value, which is quarter number 3. So quarter number 3. First find the position of quarter number 3. So we already identified the position of quarter number 3, which is equal to 60. So class for quarter number 3, cumulative frequency equal to 60 or next greater is 72. So this is the pink color highlight is class for quarter number 3. Right. So now the lower class boundary of quarter number 3 is 10995. Right. Plus the position of quarter number 3 is 60 minus the cumulative frequency before the quarter number 3 is 55 divided by the frequency of quarter number 3 is 17. So we need to multiply with the class size. The class size is 1199.5 minus 1099.5 equal to 100. So this one should be equal to 1128.91. So this is how we calculate quartile for group data and ungrouped data. So far, do you have any question? Or if you have question, you can raise the question. Do you understand? Yes, you understand, right? Okay, good. So next we move to the next topic. Can we move to the next topic, or you want to take a 5-minute rest? You want to continue, right? Good. So now we move to the next topic, which is measure of dispersion, right? So measure of dispersion. So sometimes for 2 or more groups, right, of the data, we can find the distribution have equal arithmetic mean, right? For this equality arithmetic mean, right, we can say that the data distribution, can we say that the distribution is like? So now let's say I collect a data from 2 playground. Let's say this is a playground A, this is playground B, right? So let's say I go to the playground A, I collect n equal to 10, means I collect 10, I collect age of the children. My variable of interest is age of the children. So I collect 10 children. I ask the mother about the children age. So I get, let's say the distribution is like this. And then the mean is x bar equal to, let's say, 5. Right? So I go to another playground, let's say playground B. I collect 10 data, right? And the mean also equal to 5. But the distribution that I got is like this. So can we say these two distributions are same? Since we already have the same value of mean, right? By looking at the distribution shape or distribution curve, clearly you can see that these two distributions are not equal, even though we have same value of mean, right? This is because the distribution of age in playground A is around mean, right? while the distribution of age of the children also around the mean, but it's quite dispersed, right? Dia lebih dispersed sikit, dia more spread compared to distribution A. So where distribution A dia punya spread tu dekat dengan mean, while for this playground B, the distribution of age is more spread around the mean, so dia lebih spread sikit, right? So that's why measure of central tendency alone cannot determine the shape of distribution, or we cannot say the distribution of two groups are equal or not equal, right? So we need to add some parameter, some statistic value such as variance or standard deviation to identify the consistency or the spread or the disperse of the distribution, right? So now we will learn range. So range is the simplest measure of dispersion. It measures the difference between the largest data value and the smallest data value. This is very simple. So if you want to determine range for ungrouped data, we take the largest data value minus smallest data value. So we will get the range. For group data, we take the upper class boundary of the last class and lower class boundary of the first class. Take a difference, then you can get the range value, right? Let's look at example number 35. So the smallest value, this is ungrouped data. The smallest value is 8. The largest value is 58. So range is equal to 58 minus 8 equal to 50. Right? Okay. For example number 36. So the largest data value is 10. The lowest data value is 2. So the range is 10 minus 2 equal to 8. Right? So you jangan confuse, because this is the value that we get, the actual value. This is the frequency value. So we will take the actual value only. Now we look at example number 37. Example number 37. This is a group data. We have a class size. So range should be upper class limit. Upper class boundary of the last class minus lower class boundary of the first class. So if you look at the class size, we don't have a class boundary again. So this is 2.5 to 5.5, 5.5 to 8.5, 8.5 to 11.5, 11.5 to 14.5. So range is 14.5 minus 2.5. So we will get 212 only. So daily sales, the range of daily sales is RM 12,000. Right? Okay. So another measure, another statistic in measure of dispersion is interquartile range. So interquartile range and quartile deviation measure the spread or dispersion of quartile, right? So the formula for interquartile range, the short form is IQR, which is quartile number 3 minus quartile number 1. While quartile deviation QD is quartile number 3 minus quartile number 1 divided by 2, or IQR divided by 2. So quartile deviation also known as semi-quartile range. Right. So now look at example number 30. So we have ungrouped data, right? So we want to calculate interquartile range and quartile deviation. First step, we need to find quartile number 1, quartile number 2, and quartile number 3. So we actually we don't need to have quartile number 2, right? we need to find quarter number 1 and quarter number 3. Right. So first step is we need to arrange data in ascending order. So the first data is 7, 14, 15, 17, 23, 5, 28, 37, 41, 46. Right. And then my style, we need to position each of the data. This is position number 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right. So quarter number 1. Quarter number 1. First, we need to find a position of quarter number 1. Position of 1 is 10 plus 1 divided by 4. So 11 divided by 4 is 2.75. So quarter number 1 is between 2 and 3. So 14 plus 0.75, 15 minus 14. So this one should be equal to 14.75. Right. So for quarter number 3, so position of quarter number 3, 3 multiplied with 11 divided by 4. So this one should be equal to 8.25. So 8.25 is between 37 and 41. So 37 plus 0.25 multiply with 41 minus 37. So this one should be equal to 38. Sorry. 38. So IQR, interquartile range, quarter number 3 minus quarter number 1 should be equal to 38 minus 14.75. Right. So this one should be equal to 23.25. So the interquartile range is 23.25 and quartile deviation is 23.25 divided by 2. So this one should be 11.625. Right. So far, do you have any question for calculating interquartile range and quartile deviation? This is very this is a repetitive work, but what I want to emphasize is how we going to calculate interquartile range and quartile deviation. Right. So let's look at example number 39. Right. Can we continue? Example number 39. We just want to continue until example number 40. Then we take a 5-minute rest. And we will continue for box and whisker plot and measure of dispersion for variance and standard deviation. Right. So computation of interquartile range. We need to compute interquartile range and hence quartile deviation for the following group data. So this is very simple. I just don't want to do a repetitive work. So you need to this is your homework. You need to find quarter number 1 and quarter number 3. So I give you the answer of quarter number 1 is quarter number 1 is equal to 8 seconds. Sorry. Quarter number 1 should be equal to not 8. This is quarter number 1 is equal to 1. Quarter number 3 is equal to 3. Right. So interquartile range, quarter number 3 minus quarter number 1. So this one is equal 3 minus 1 equal to 2. Quartile deviation sama juga quartile number 3 minus quartile number 1 divided by 2. So 2 divided by 2 is equal to 1. Right? So make sure you calculate quartile number 1 and quartile number 3 by your own. Right? So now look at example number 40. So don't worry, this one I will give you at Google Class. So this note I will provide in Google Class note, Google Classroom. Right. Now look at example number 40. In example number 40, same as example number 39, I want you to calculate quartile number 1 and quartile number 3 by yourself. So I will provide the answer. Right. So quartile number 1 should be equal to 8 seconds, and quartile number 3 is equal to 11 seconds. Right. So interquartile range, quartile number 3 minus quartile number 1. So this one 11 minus 8 should be equal to how much? Is equal to 3, right? And then quartile deviation, quartile number 3 minus quartile number 1 divided by 2 is equal to 1.5. So remember, this is your homework. I want you to calculate quartile number 1 and quartile number 3 for example number 39 and 40, right? So I already provide the answer. Okay. So far, do you have any question? You can comment in chat room if you have question. No question, right? Good. So means you understand, right? How today we are so far we already learned how to calculate quartile number 1, quartile 2, quartile 3 for ungrouped data and group data. And then we also know how to calculate range, right, for ungrouped data and group data. And we also learn how to calculate interquartile range and quartile deviation, right? So the next plot is the next topic is a box plot, box and whisker display, right? So box and whisker display, basically in our subject, right? Wait, right. Box and whisker display, right, also known as box plot, right? So we have a box and a whisker. So this is the box and whisker display. So the value involved in box and whisker display is, this is minimum value, this is the maximum value, this is quartile number 1, and this is quartile number 2, and this is quartile number 3, right? Okay, so to compute box and whisker plot or box plot, you need to have these 5 elements. The first value that you need to find is the minimum value, quartile 1, quartile 2, quartile 3, and the maximum value. So if the box plot look like this, let's say the quarter number 2, this is quarter number 1, quarter number 2, quarter number 3. So if the area of quarter number 1 to quarter number 2 is larger, right? Let's say this is right. When the area on the left hand side is larger than the area on the right hand side, right? So this is what we call as a skewed to the left distribution. So you can see area on the left hand side is bigger than area on the right hand side. So this is what we call skewed to the left distribution. Okay, so skewed to the left distribution because the area on the left hand side is bigger than area on the right hand side, right? On other point, if we see that another pattern where the area on the right hand side is bigger than area on the left hand side, so this is what we call as skewed to the right distribution. So you can see area on the right hand side is bigger than area on the left hand side, right? So this is what we call as skewed to the right distribution. Skewed to the right distribution. So when the area on the left hand side and the area on the right hand side are same the area are same, so then this is what we call as a symmetrical distribution. So the area on the left hand side same as the area on the right hand side, so this is what we call as a symmetrical distribution or normally distributed, right? So basically you can understand the pattern of the box plot. When the area on the left hand side is bigger, then this is a skewed to the left. When the area on the right hand side is bigger, then this is a skewed to the right. And when the area are equally same on the right and the left, so this is what we call as a symmetrical distribution or normal distribution, right? So I hope you can understand the shape of distribution based on the box plot or box and whisker plot, right? So are you clear with this one? So we need to understand the shape of distribution. Again, I'm going to emphasize that when the area on the left hand side is bigger, then this is a skew to the left. When the area on the right hand side is bigger, then this is a skew to the right. And when we have the same area between on the left and the right hand side, so this is what we call as a symmetrical distribution, right? So I hope you understand, right? Right. This is example number 33. Just copy back. So now, to draw a box and whisker plot, so the minimum value here is 14, right? And the maximum value is 84. So we need to create a line. See, this is, oops. So this one, yeah. So this one represent the minimum value, which is equal to 14, and this is equal to 84. and quartile number 1 is equal to 26.75. Let's say this is 26.75. You need to measure it correctly, and this is equal to 50, and this is going to be 66.5, right? Okay, so to draw a box and whisker plot, so you kena ada whisker dulu kat sini, and this is the line for quartile box, the first box, and then this is the end of the box, right? And this is the maximum value. So you tarik lah. Better you use a ruler, dan you akan nampak cantik sikit, right? So this is the quartile number 2. So if you can see, if you measure it correctly, right, you can see the area on the left hand side, right, the area on the left hand side is larger than area on the right hand side. Actually, you don't need to color, but I just want to show you the different the area size, right? So since the area on the left hand side is larger than area on the right hand side, so this is skewed to the right. So this is a skew to the left distribution, right? This is how we draw a box and whisker plot. Right, do you have any question on how to draw a box and whisker plot and how to interpret box and whisker plot? So basically, in box and whisker plot, you need to have the minimum value, quartile number 1, quartile number 2, quartile number 3, and the maximum value. So this is the simplest way to construct a box and whisker plot. There is another way, but we're not going to learn that the complicated way in this subject. We just need to understand 5 measurement, 5 summary of statistic to construct box whisker plot and how to interpret box and whisker plot, right? So how to determine which area is the largest? So you need to get the difference. 50 minus 26.75 is how much? 50 minus 26.75 is 23.25. 66.5 minus 50, this is 16.5. So of course on the right left hand side is more than right hand side, right? So by then we should take a 5-minute rest or 10-minute rest before we continue on. We can determine quartile 1, quartile 2, and quartile 3 from less than or give. So let's say we look at example number 34. Like, so let's say we draw a less than or give. See, this is y-axis, right? And this is x-axis. So the lower class boundary is 699. So let's say 699.5. This is 799.5. Let's say this is 899.5, and this is 999.5, and this is 1099.5, and then we have 1199.5, and the last one is 1299.5. So the cumulative frequency, this is a cumulative frequency. Cumulative frequency represent number of employees, right? The class boundary represent monthly income, right? So this is, let's say, kita panjangkan sikit. This is 75 and this is 80, right? So this is number of employee. This is a capital F. So to draw a less than or give, we start with the lower class limit of the first class, which is equal to 0, and less than 799.5 is equal to 10, right? And less than 899 is equal to 22. So 22 somewhere here, right? And 999 is 47. 47 is somewhere here. And then 55 is somewhere here. Oh, tak, sini. And then 1000. Oops. 1099 is 55. 1199 is 72. 72 is somewhere here. Let's see. And 1299 is 80. Is somewhere here. Right. So then you need to connect the line, connect the point with the smooth line. Right. So you will get a less than or give. Basically, it should be smoother than this, right? So to find quarter number one from a less than or give, this is a less than or give, right? So to find quarter number one, we need to find the position of quarter number one. Position of quarter number one for this example is 20, right? So you need to find 20. So this is quarter number one. So this is quarter number one. So quarter number one should be equal to 882 point something, 2.5, for example, right? So this is just an estimate. If you draw a correct measurement, you will get the exact value of quarter number one, right? For position of quarter number 2 is equal to 40. Right? So you need to draw. This is from 40. You will get position number 2, quarter number 2. So this is quarter number 2, which is equal to 800. Sorry, equal to 970 something kan. So you will get around the exact value, 970, 1.5. If you do a correct measurement, you will get 971.5. And position of quarter number 3 is equal to 60. Right? So 60 dekat sini. Right? So you will get this is quarter number 3, which is equal to 128.91. So if you draw a exact measurement, you will get exact value. Right, so this is how we compute or we determine quarter 1, quarter 2, and quarter 3 or from a less than or give. So the question is, well, why when the area of the left whisker is larger than right, is called skewed to the right. In the book, say skewed to the left. Mana? When the area on the right hand side is smaller, then it's skewed to the right hand side, left hand side. So this is make a correction, right? So this is a skewed to, this is a symmetrical distribution, right? And this is skewed to the left, and this is skewed to the right. Right. Okay. Good. All right. Very good. Nabil, you correct me. So when you have the area on the left hand side is larger than area on the right hand side, this is skewed to the left. And when the area on the right hand side is larger than area on the left hand side, so this is skewed to the right. All right, thank you very much. Good. And then the correction for this one, so we will get skewed to the left distribution. So this is also skewed to the left. Right? Okay. Any questions so far? So far, until now, we already look at how to calculate quartile 1, quartile 2, and quartile 3 from for ungrouped data and group data. And then we also look at how to calculate range, right, for ungrouped data and group data. And we also look at how to calculate interquartile range, right? Interquartile range for ungrouped data and group data. Interquartile range is just quartile number 3 minus quartile number 1. Quartile deviation is quartile number 3 minus quartile number 1 divided by 2, right? And then we also look at how to find quartile 1, quartile 2, and quartile 3 from less than or give, right? So So now, we need to move to the next topic, which is our last topic for chapter number 3, right? Which is variance and standard deviation, right? As I said before in the beginning of the class, right? If you want to see whether the two distribution are in same size or different size, or if you want to compare between the two distribution, whether these two distribution are same or not same, so you need to add another parameter, which is another statistic, which is variance and standard deviation, right? So variance and standard deviation are most popular measure of dispersion, right? We can compute variance and standard deviation for both sample and population, right? So in this chapter, we will only calculate sample variance and sample standard deviation. So the definition of variance is the sum of square of difference between each data value and the mean divided by sample size minus 1. So the standard deviation is a square root of variance. So this is the formula for variance for ungrouped data. So there are two formula for variance. This is formula number 1 and this is formula number 2. So in my class, we will always use formula number 2 because it's easy to calculate and easy to find summation of x squared and summation of x squared, right? So this is a symbol for variance is s squared. See, this is a sample variance, right? For population variance, the symbol is sigma squared, right? So we will use this formula. S squared is equal to summation of x squared minus summation of x, and then u squared divided by divided by n, and everything divided by n minus 1, right? Right. So this is a formula of calculating variance, a sample variance for ungrouped data. This is for ungrouped data. So for standard deviation, we just take a square root of variance. So we will get the standard deviation. For group data, they also have two formula. This is formula number 1 and this is formula number 2, right? So we will focus on formula number 2, right? So because it's easy to calculate summation of fx square and summation of fx and u square, right? So this is a complicated formula. We will abandon the first formula. So sample variance for group data is summation of fx square minus summation of fx and then u squared divided by summation of f divided by summation of f minus 1. Same as ungrouped data, sample variance, standard deviation is equal to the set of standard deviation variance, right? And you need to understand summation of x square is not equal to summation of x and then u square. And for ungrouped data, summation of fx square is also not equal to summation of fx and then u square. It's a different value, right? So now look at example number 42, right? In example number 42, right, example number 42, we want to find variance and standard deviation for this data. This is ungrouped data, right? So For ungrouped data, S square is equal to summation of X square minus summation of X and then U squared divided by N minus 1. Right? So this is the X value. And then you need to find X square. So this is 936, right? For the first value, kan? Let's say we put it into the box, into a box, so we can get a nice view. So let's say X here, and this is your X square. This is 3, 6, 9, 12, 15, 18, right? And last is total. So this is 3 power of 2 is 9. This is 36. And then this is 81. And then this is 144. This is 225. And the last one is 324. Right, this is a total, right? So the total of X, summation of X is equal to 63. And total of X square is equal to 819, right? And we have N equal to 1, 2, 3, 4, 5, 6. N equal to 6. So to find the standard variance, right? So summation of X square is 819 minus summation of X is equal to 63, and then you squared divide by N is equal to 6 divided by N minus 1 equal to 6 minus 1. So this one should be equal to 31.5. Or if you want, this is the variance, sample variance. And if you want to find the standard deviation, the surd of variance, which is also equal to surd of 31.5 is equal to 55.612. Right. Okay. So until now, do you understand how to calculate variance and standard deviation for ungrouped data? Can you comment on the chat room? Right. So today we already learned a lot. First, we already learned how to calculate quartile 1, quartile 2, and quartile 3 for ungrouped data and group data. And then we also learned how to calculate range, right, for group data and ungrouped data. And we also know how to find quartile 1, quartile 2, and quartile 3 from less than or give. We also know how to find interquartile range, which is quartile 3 minus quartile 1, and quartile deviation for interquartile range divided by 2. And we learn a bit how the variance, a sample variance, a sample standard deviation for ungrouped data. We just learn the formula. So we will continue by tomorrow, right? Because we already have learned 1 hour and 45 minutes. Right, I think that's enough, right? We shall continue tomorrow. So tomorrow we will continue on variance and standard deviation for group data, and then we will learn coefficient of variation, and the last one is coefficient of skewness, right? So there are a lot more, right, to understand. I will teach you how to use calculator to find variance, sample variance and sample standard deviation, right? So far, can you comment if you have any question, or if you don't understand, you can raise a question on the chat room.